Hello, everyone. My name is Akin Aregbeshola. Welcome to the first in a series of lectures I'll be delivering under the title Information Technology, Your Place and the Path to It. In this series, we'll be looking at terminologies like IT and telecommunications. What is a cloud engineer? Who is a solutions architect? Who is a business analyst? What is the place of Internet of Things? What do we mean when we say big data, machine learning, artificial intelligence, blockchain? What is the place of 5G in all of these terminologies? And what do we mean when we say gig economy? The goal is to help you understand IT holistically with a view to determining where you fit in and how you can migrate from where you are now to where you see yourself in the next 6 months, in the next 1, 2, 3, 4 years. Today, we shall be looking at the topic, what is IT? What is information technology? In IT, we call computers, laptops, tablets, mobile phones, whatever it is that is connected together in a network, we identify them as machines. So machines could be standalone. In that case, they are not part of a network. For example, you have your laptop, it's not connected to the internet, it's not connected to the corporate network, it's not connected to any other device outside of itself. You would say that laptop is a standalone. If you have a mobile phone that is not connected to your mobile network and therefore has no access to any other mobile phone, then that mobile phone is standalone. You have a computer that is not in any way connected to any other device outside of itself, that computer is standalone. Therefore, these kinds of standalone machines are not relevant. They are not the kind of machines we're talking about when we refer to machines in IT. When we talk about machines in IT, we are referring to machines that are connected to other machines via networks. So networks will be a connection of multiple machines in such a way that they can see one another and they can share resources amongst themselves. So if you have a mobile phone and the mobile phone is such that it can connect to other mobile phones around your area, around your country, around the world, then that mobile phone is on the network. If you have a computer in your office and through that computer, you can connect to the computers of your other colleagues in the office. You can connect to computers in your head office. You can connect to computers anywhere else outside of your immediate vicinity, then you say that computer is on a network. So the whole goal of a network is to be able to not just to connect computers together, is to be able to share resources. So the reason you want to have a network between phones is so that you can transmit voice from one node of the network represented by one phone to another node of the network represented by another phone. The reason you want to have a corporate network within your bank, for example, is to be able to share the customer's database, which is centrally located on some server on the network, so that every other person that you want to give access to would also have access to that central database. So the whole essence of networking is to share resources, to have access to a common resource. All right. In big networks, these resources could be very many and of different types. On small networks, it could just be data. It could just be sharing of internet. It could just be sharing of printers. In information technology, we refer to small networks as SOHO, or small office networks, and we refer to big networks as enterprise. Right? So when you have a corporate network, for example, within your bank, and you are connecting that corporate network over a long distance to your bank head office, for example, your branch office in one part of a country to the head office in another part of the country, over a distance of, say, 300, 400, 500 miles or kilometers, then that's going beyond IT. The part of technology that is responsible for taking the data from one end at the customer, at the branch office side, and connecting it to the other end at the head office side is a long haul. So that part is called telecommunication. And that is where you talk about transmission medium and transmission media, such as copper, could be fiber, could be RF. In that case, you would need to install radio antennas, connect them to, RF antennas, connect them to RF radios, and then through your cables, link them to routers and so on and so forth. All right, so to distinguish between that part where the focus is on moving data, running traffic from one arm of a network to another arm of a network, particularly when the other arm is far away, far apart from the source network, then we talk about telecommunication. Whereas when we are dwelling on just one arm of the network and looking deeply into it in respect to what can be generated and transported within that arm of the network, then we're looking at IT. All right, even though they are closely related, this is the small difference between them. So on a network, for example, a network of 20 computers, 200 computers, 700 computers within a premise, within your 25-story bank head office, for example, because your computers, your servers, your cables, your routers, your switches, and all the other devices that you need on the network to make the network work, to make the computers work and make the interconnectivity between all the 20, 500, 700 computers work. All these network elements, like I mentioned, from cabling to switches to routers to radios to every component, every single network component, including the servers and computers on that form part of that network, is referred to as network infrastructure. And this network infrastructure would be within your bank premise, in the case of this 25-story bank head office. And because they are physically resident within the bank premise, some on floor 1, others on floor 2, 3, 4, and so on and so forth, you call the entire premise an enterprise. All right? So when we talk about enterprise network infrastructure, we're talking about physical devices that work together to make your networking possible. All right? So the primary devices that will come to mind will be servers. Servers would be the computers on the network that houses the resource that you want to share on the network. If the essence of having a network is to share a database, then you will put that database on a computer and make that database available to all other 500, 700 computers on the network. In that case, that computer that houses your database is your server, your database server. If what you want to share what you wanted to share on the network was internet. You put the internet on a particular computer and then do some configuration to make that internet on that computer available to all other 500, 700 clients, you may want to call them, generally called, whether you call them nodes, clients, or even workstations. These are terms that you can use to describe other computers in order to distinguish them from the server, right? Ordinarily, they are all computers, but by the virtue of responsibility that is attached to a particular computer, it could be called a server. In the case that I just explained, that computer would be your internet server. Okay, there are better names, but I don't want to introduce technical terms right now. Just leave it as internet server. So if what you wanted to share on the network was a file, so that every 700 computers on the network would have access to that file, then it will be file server. So you have servers within your enterprise, and that server would be part of many network infrastructure. If I say name 3 other kinds of infrastructures apart from servers, I expect you to mention switch, for example, which is the device to which you run cable from one system and then run cable from that device to all other systems, so that through this device, through this piece of equipment, all devices are connected together using cables. So that is the way you network. You have a device that you literally placed in the center of the architecture. So by the time you run a cable to one system A, another cable to system B, another cable to system C, and so on and so forth, it forms a kind of arrangement that looks like a star, with the switch in the middle and all other computers surrounding the switch and connecting to the switch using data cables. That's where the term star topology comes into play. And then the architecture of that star topology, even though you already have that arrangement, that physical arrangement, the architecture, the technology that drives it, the way you terminated the cables using RJ45, and the protocols that drive traffic on those RJ45. Together, the topology and the terminologies come together to form what we call the Ethernet architecture. Ethernet is different from internet. One is Ethernet, the other one is internet. All right, so Ethernet simply means a local area network. If you want to take a deeper look, it means a local area network where you are using a switch as the central device to connect all the computers, and then you are using data cables terminated on RJ45 plugs as the connecting medium, usually, yes. And then, of course, you have the other protocols, that is driving the technology, the multiplexing, the duplexing. Don't worry about these other details, but there are protocols that ensure that when you send traffic on one computer, it eventually arrives at the other computer. But that's too deep. Just the first of the series of lectures. All right. So now you have an idea what we mean when we say enterprise network infrastructure. All right. So in the case of your bank again, the bank premise on which your network infrastructure resides, along with the network infrastructure that reside there, together they are enterprise, right? Enterprise network infrastructure. But there is a different kind of infrastructure, so to speak, where you don't necessarily have to have this physical infrastructure in your bank. It could have been done somewhere else. All right, your servers, your cabling, your Ethernet, your switches, your routers, and everything else, even the operating system that you need to put on your server, all of them are already established by someone else outside of your premises. In that case, you would only be accessing those resources, not physically within your premises, but remotely on someone else's premises. All right, so this place where this infrastructure are already housed, they are maintained, they are working fine at all times, they are up almost 100%, 99.99% in most of the cases. All the antiviruses you should be buying, you don't need to buy them. All the expansion you would need in case you need additional memory or additional storage space or even buy additional servers, you don't need to do any of them. All of that is already done by a third party. And all you do is just from a laptop, connect to this remote network infrastructure and gain access to these services as if they were resident in your premise, as if they were enterprise-based. All right? So when you have this kind of arrangement, it is no longer a physical thing, it becomes a virtual thing because the servers, and routers, and firewalls, and applications and software that you are dealing with, they are not resident within your premise. They are not, you don't see them. They are not physical. They are somewhere. In fact, you don't even know where they are. You may not even know where they are. All you know is you have access to them whenever you connect to them. So that kind of scenario compared to the earlier scenario where you had them physically in your server room within your premise, this other scenario is called cloud service. And that their own server room where all of these infrastructures have been installed and are working, that place is called data center. So data center is the physical warehouse where you have installed all the network infrastructure that you normally would have in your premise. And then the services provided resulting from this data center installation is called cloud services. And the big difference is it's not physical to you, it is virtual to you. Unlike your enterprise infrastructure, you can physically see the server, you can physically see the cable, you can unplug and plug if you want, and all of the physical presence that is peculiar to enterprise network infrastructure is not the same for data center stroke cloud because the services are already made available remotely in the data center, and by cloud services, you can access them, all right? So the software that run on your network infrastructure in cloud and the software generally, sometimes these softwares are the operating system level. At other times, they are the application level. In other words, you already have your operating system like your Windows, but on top of your Windows, you are now putting an application like your database. If for the database we mentioned earlier, if for example, you have your database on, what's a popular database application? Oracle. Your Oracle would need, it's an application in this case, you would need an operating system to run on. The Oracle as a software, as an application, would normally run on Linux as an operating system. So the Linux operating system on which your Oracle runs would be your platform. And the Oracle that runs on your Linux operating system would be your application, right? So both your application and your platform require physical servers physical network infrastructure to live in, to stay in. All right. So these are the three layers on which your services would operate in order to be available to you. The application layer, generally called software, the platform layer, generally the operating system and all the protocols and services that support that application, that software on that operating system. And then, of course, the physical server with 16 meg RAM or 64 meg RAM, whatever it is, and then the relevant RAM speed and storage capacity. That is the infrastructure. So your platform will run on your infrastructure and your application will run on your platform. All right? The whole essence of setting up a network, because we're still talking networks now, whether we're talking networks within your enterprise or we're talking networks that you connect to through your cloud services, networks that you connect to in a data center through your cloud services, they are all networks. Whether the network is a small network of just 2 devices or 3 devices within your home, or a big network of 20 million mobile phones belonging to some 4G company, they are both networks. All right? Be a small network, could be a big network. It's just that the devices and the types of equipment they run, one will be SOHO, small equipment, small devices, compared to the other one that will be enterprise, big equipment, big devices, and therefore much more expensive than your small office, home office device. For example, I could show you a tiny router that I use at home, and that is just because it's connecting 2, 3, 4, 15 computers. That is not the same router that will be used at enterprise level to connect 500, 700, 7,000 computers. All right. So routers are different in many ways, but in one way, depending on what network is the router serving. Routers that serve small networks are called small office, home office routers, and routers that serve big networks are called enterprise routers. And by the way, I'll be discussing routers fully in another topic so that we know what routers do exactly on the network. And then to conclude this part, the whole essence of setting up a network, especially at the corporate level, is that you have a solution. The solution is an application that you have built to solve a problem, a software that you have developed and placed on a server to address a particular problem. For example, if the problem you want to solve is as a bank or as a finance institution, you want to automatically, because when you pay people, when you pay your customers, their full entitlement, their full salaries, their full income, it is difficult. You have observed that it is difficult to make them pay their taxes. So that is a problem. What you want to do is to have a solution that would automatically deduct taxes from all your customers' income before the remaining income is released to them. All right. So that software that will scan through all customer accounts and extract 1%, 2%, 10% of their income as tax and then forward that one to the government. That software is a solution. All right. So in this case, the problem you are solving is that one, and the solution is a software that sits on the server to do that job. All right. This kind of solution are generally called solutions in this kind of applications are generally called solutions in IT. So when I say a solution, it means that the software, the application that organization, that company, that individual has developed to solve a particular problem. All right. So what is IT then? Everything I have described, from cables to routers, the planning, the designing, the deployment, the setup, the management of all of this infrastructure to ensure that they are always up and working to connect the 500, the 700, the 1,000 devices that they should be connecting, and that the application, the solution that you have developed is working fine and doing its work. Everything related to what we have described with the goal of ensuring that the solution is always up and running is information technology. All right, so you see that information technology is very wide, very wide, very wide, right? So it would also cover not just the physical infrastructure and their connection. In fact, that is just a tip of what IT is all about. But more importantly, accessing the operating system on which your Oracle runs. Who should access it? Who should not be able to access it? How do you develop it so that in 5 years, it should be able to do more than it is doing now? Okay. At the operating system level, what about at the application level? Okay. So development, administration, accessing, restricting access. I mean, allowing this, not allowing that, what protocol? What about people coming to sniff your network and attempting to move that money that you have extracted from taxpayers for the government? What about people that would attempt to come and steal it? What do you do to prevent theft on your net? So everything related, not just at the physical level, but also at the operating system level, at the application level, everything related to ensuring that your the infrastructure, the application, the network is always up and running. Is also, in fact, is the main information technology. All right, so I would say progress will be addressing the different phases of information technology and the different areas, like, let me not mention them now. Okay, the different areas of information technology that that could come up in order to take care of different aspects of this simple scenario that you just painted, so that one man is not responsible for all the aspects of information technology, but different people specializing in different aspects, but working together as a team to ensure that that department meets the objective of making information continuously and always permanently available in a secured manner to the users, whether they are customers, whether they are clients, whether they are whatever name you want to call them, of that network. All right. So that's an overview of what information technology is. All right. So like I said, information is wide. The different aspects of IT, different aspects of information technology have reigned during different eras of development, right? At one time, some 50, 60 years ago, 70 years ago, it was the industrial age. It's not the same Pascal, Fortran, and other information technologies that you learned then that were used to deploy the digital age when internet became, the Yahoo age, when internet came into being and everything was moving online. And it's not necessarily those same technologies that we learned 20 years ago, 15 years ago, 17 years ago that are relevant in today's economy. Today's economy is called the gig economy, right? So the arm, even though information is even though IT is very wide, the arm of IT that is mostly, more than 50% responsible for the growth of the kind of economy we have today is built around cloud. I already gave you an idea of what cloud is. So alongside cloud, there are other IT specializations that are relevant to the architecting, the development, the deployment, the security, the availability, reliability, scalability, and everything about cloud. All right. So this is the way to go it is around these IT specializations that will make cloud solution fully available at a cost, fully available cost effectively. This is the way to go. And when we say information technology, when I particularly say information technology, this is what I have in mind, even though it's a very broad topic. What I have in mind is cloud and the relevant IT specializations that will make cloud work in such a way that it will be available to all and people can deploy their solutions. Remember how we describe solutions? Banks and not even established banks, even young entrepreneurs can wake up and develop applications, put them in cloud and run them to solve one life problem or another, one problem here, another problem there, and effectively make the world a better place by those contributions. All right. So that's it for today. Tomorrow we'll be taking another topic and examining it from a different perspective so that we get to understand IT better and better. Thank you very much.